Hello everyone, Rex here again with TorchPrep. I'm back at it doing more math questions. I am in test 3, problem number 51. So, what I need you to do is pause this video right now. Go ahead, open your red books to number 51 in test 3. Read the question. When you're ready to go, press play. Okay, excellent. We are still in the word problem strategies concerning the floor plans of all of these storage spaces. And again, word problem strategies, you can always skip them if that is something that wastes your time, you go too slow. You can do them in the work portion. We skip, circle that number, and come back to it in the work portion. That's okay, but honestly, if you know our word problem strategy and you've been practicing it, most of these are not too hard. And in this set of 3, 50, 51, and 52, I'm sure you can tackle all of them just fine with our strategy. The math inside is not too tough. So, in our word problem strategy, we always start with number 1. What are we trying to find? We're trying to find the number of size 1 floor plans that can fit inside size 5. Awesome. So, step 2 of our word problem strategy, we ask, what do we already know? I decided it's better for this one to use our other code cracker of drawing a picture. Drawing a picture is so helpful. So I drew down here a representation of size 5. It is 16 by 8, and size 1, which is 4 by 2. Also, I have all the measurements and monthly rates of size 1 and size 5 there on the table. So, if I'm trying to figure out how many of these fit in here, one of the first things I'm worried about is, since neither of these are squares, I need to make sure that an even number of these, or a whole number rather, of size 1s will sit in size 5. The way I'm going to do that is I need to make sure that these two shapes are similar, meaning that their dimensions are proportional. So, if this is the proportion of size 1, and this is the proportion of size 5. These both equal out to be 1/2, 1 over 2. So the good news is, since these are similar shapes, I can fit a whole number of size 1 in size 5. That's great news. So now all I want to do is find the area of both, and I'm going to divide the area of the larger, size 5, by the area of the smaller. The number that I get will be the number of size 1s that will fit in size 5. So, what is the area of size 5? 16 times 8, because we have a quadrilateral. It is base times height. That equals 128. Now, let's do the same formula over here. Base times height, 2 times 4, 8. So I'm going to divide 128 by 8. That is the area of the larger size divided by the area of the smaller size. And see how many whole numbers of size 1 we can fit inside. And if you throw that in your calculator, you will find you can fit 16 size 1s inside size 5. That is the correct answer and the letter answer of E. Great job.